Okay, hello guys. Welcome to this class on functions. We are going to be covering IGCSE Add Maths functions in one shot. Okay, in 30 minutes, I'll try to cover all the concepts of functions, around 90% of the concept. Okay, all the important concepts. Some concepts are slightly complicated and it cannot be covered in 30 minutes. So I will just highlight to you the main points. Okay, if I feel like something needs to be explained, I might go slightly longer than 30 minutes, but if you're in the class, then it's more beneficial for you. You can ask questions on the complicated concepts. And if you're at home, you feel it's getting too long. If you're watching it on YouTube, if you feel it's getting too long, I would suggest you watch it in 1.5x speed. Okay. But other than that, I will cover all the concepts of functions in detail. So I'm going to be sharing my screen and we're going to start. Okay. This is one of the first chapters which you usually do when you start Add Maths. Sometimes you start with some other chapters, but this is usually the first chapter you'll do. And it's many times very complicated. So I'm going to make all the concepts crystal clear as much as I can because it's a short amount of time. Okay, so let's start. Now, functions is a very complicated term, but the easiest way I like to think about a function is a machine in a factory. Okay, so like I draw a box here. It's a machine in a factory. So what happens in a machine in a factory? So suppose in your factory, the factory is about Yakult, suppose, you know, Yakult, the energy drink, not really energy drink, but like it's some tasty drink, it gives you energy. Okay, so suppose it's a Yakult factory and this is one of the machines. Okay, I like to think about functions as machines. So suppose raw Yakult, as in like liquid Yakult comes in, and what the machine does is it packages the Yakult into the Yakult bottles. So what it does is it packages it into the Yakult bottles, okay? Because you can't sell liquid Yakult in the shops just like that, right? That's not how it works. So that's the function which the machine has done on the liquid. It's packaged it. The function which is done, it's packaged the Yakult. Now, this is maths. This is not Yakult. So what the machine is going to do, what this function is going to do, is it's going to do operations on numbers. Okay, it's going to do operations on numbers. So suppose I have a number which comes into my machine. And obviously, because a number has came into my machine, a number will go out of my machine. So suppose that number is 9. Okay. Now you'll be wondering, what have I done to this number? There are multiple things I could have done. I could say I have multiplied by 3, added 6, squared, whatever. I have done something to this number. Let's say the same machine, if I pick 4, gives me 16. The same machine, if I put 4 inside, it gives me 16. Now, if I put 5 inside the machine, it gives me 25. Now you can have an idea that like how Yakult machines, they package the Yakult. That's the function this does. This machine, the function it does is that it squares the incoming number. So it squares it. Okay. Now let's get, this is the general concept of functions. Now let's get more into the terminology behind. Okay. Functions. Suppose I let the input, because the input can be anything, right? 3, 4, 5, 6, 7, 8, 9, blah, blah, blah. Suppose I let that input be x. Okay. So a function in which x is the input is denoted like this. F bracket x. In which x is the input. Yeah. Y could have been the input. Then it would have been f bracket y. But in this case, if I'm saying it's x, then it's fx. Okay. Don't think it's always x, but x is the most common one. So in this case, fx equals to x squared. Whatever number goes inside, it becomes squared. That's how you actually say it. Now, let's get more into the terminology. As I said, this input in maths is given a name called domain. Okay, and this output is given a name called codomain. Now, many of you who are learning this for the first time, there's no problem. Okay, but if you are revising, you'll be like, huh, I thought output was called range. No, the output is not range. The output is codomain. Then you'll be wondering, what is range? What is range? Range is the highest and lowest value of codomain. Okay, so suppose for fx equals to x squared, I can actually put anything inside x squared. But suppose I tell them, suppose the machine says that this is the notation that x is let's say x is between 9 and between 3. You need to get used to this notation, yeah? Of course, I could have put anything inside the machine, but it's saying, hey, x is between 9 and 3. So not 3 and 9, yeah? I have look at the symbols. It's not 3 and not 9. So I will have many different codomains, 3 squared, not 3, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, right? So the range is the highest codomain and the lowest codomain. So the highest codomain would have been at 8 squared. If these are integers, okay? Otherwise, you'll say, oh, Shamat, 8.99999, okay? If they are integers, it'll be 8 squared. So 64 will be the highest and the lowest will be 16. So how we will denote it? This time we can say equals to, like this. Okay? What if they are not integers? What if it can be 8.99999? Then it'll be lesser than 81 because 9 squared is 81, but it can be 8.999. That's lesser than 81 and lesser than 9. This is the range. Remember, 9 and 81 are, I would say, codomains, but not the codomains because 3 and 9 are not inclusive. But if you do it, like how we did earlier between, this depends. Okay, if x is an integer, suppose it says x is an integer, then it will be between 64 and 16. These are two values of codomains. These are the highest and lowest codomains. That's the range. Okay. Now, I hope that was crystal clear with you. You can practice some questions in your textbook. Okay, we won't have much time to practice questions here. This is just all the concepts for you. Okay. Now, there's this thing which you learn early on called mappings. Okay. Mappings is a very simple concept. I have domains and I have codomains. Now, if one domain gives me one codomain, it's called one-to-one. Now, Shamit, what do you mean? Okay, in this case, I can give you an example. Suppose fx is equal to 3x plus 5. Okay. Now, suppose I'm choosing my domain as 2. I write it like this, f2. So I replace the x with 2 as 3 times 2 plus 5, which is equal to 11. Now, if I chose a domain of 2, it gave me a codomain of 11. Now, I have a few questions. Is the domain of 2 the only domain which can give me 11? Can any other number give me 11? I don't think so. If I choose 3, I'm getting 14. If I choose 4, I'm getting 17. 2 is the only number which can give me 11. And is there any other number, any other output which can give me 2 as the input? I'm thinking, I want 2 as my input for an output other than 11. Not possible. See, so I can't have 11 in any other way apart from 2, and I can't have 2 in any other way apart from 11. So that's called one-to-one. So means one unique domain gives me a unique codomain. It's unique. Okay. Some examples of one-to-one. I can give you so many examples. Linear functions, exponential. If you've already done exponential, then great. Okay. But some of you might be seeing this. If it's the first chapter you're learning, then you don't know what exponential is. You'll get to know exponential. Then you learn logarithmic. Okay. Most of us might already know what logarithmic is if we are revising. Then there is hyperbolas. Okay, all of them are one-to-one functions. Okay, then there's this thing called many-to-one. Many-to-one, for example, let's take an example. Fx equals to x squared plus 1. Suppose I take 2 again. I'll get 2 squared plus 1, which is equal to 5. Now, let me ask you the same questions. Okay, is it possible to get 5 with any value apart from 2? I want 5. So 2 is giving me 5. Okay. 2 is giving me 5. Can any other number give me 5? You'll figure out, yes. -2 will also give you 5. Oh, wow. So means 2 different numbers gave me the same number. Gave me this 2 different domains gave me the same codomain. Now, suppose this is actually called many-to-one already because many different domains, it's more than one, right? 2 and -2, they give you 5. They give you 5. So I have one question now. Can 2 give you any number other than 5? Or in this case, can 2 give you any number other than 11? You'll be like, no, Shamit, if I put 2, I will only get 11. In this case, if I put 2, I'm only getting 5. I put -2, I'm only getting 5. So in that case, it's still unique. But I can have multiple different domains give me the same codomain. But it'll be the same codomain. F of 2 will only be 5. It can't be anything other than 5. But 2 different numbers can give me 5 in this case. So that's called many-to-one. Many different domains. I know it's only 2, but 2 is still more than 1. More than 1 is still many. So many different numbers can give me 1 codomain. Okay. Quadratics are the best example of this. Okay. And if you want to see it graphically, you can see it like this way. This is the y-axis and this is the x-axis. Okay. You could see this is one value here and this is one value here. Both of them are actually giving you the same y value here. So many values are giving you the same y value, many-to-one. Okay, usually linears are like this. See, all of them are distinct. All of them are unique. Okay, then there are also other mappings which are one-to-many and many-to-many. Okay, I don't think there are many issues with that, so I won't spend so much time going into those. But just in case you want, I'll just very quickly give you an example. Suppose fx is equal to plus minus square root of x. You can see if I put 2, I'm getting plus minus square root of 2. Means one domain is actually giving me multiple codomains. In this case, if I put 2, 11 is the only thing I can get. If I put 2, 5 is the only thing I can get. -2, 5 is the only thing I can get. But in this case, if I put 2, I'm getting plus minus square root of 2. And I can't get plus minus square root of 2 from anything other than 2. Here I could get 5 from 2 and -2. Here I can only get plus minus square root of 2 from 2. This is called one-to-many. Then there's also many-to-many. I don't want to give you an example of many-to-many. You'll get confused. It's a circle. Basically, a circle is actually many-to-many. But I won't give you many examples of that. What's the point of all this? Okay, because they don't usually ask you questions on this. The point is only one-to-one and many-to-one mappings are considered functions. Only these two are considered functions. Okay, only these two are considered functions. If you want to know why, let's not get into too much detail about that. Okay, if you really want to know, then I'll get your feedback. Okay, I'll get your feedback from those who are in the class, and if you're watching it from YouTube, from the comment section, I'll get your feedback. If you want to know, then I can make another video on that later or another class on that later. Right now, let's just skip that. Okay, so we've covered domain and we've covered range. Okay, one thing it's important to know is that there are certain domains which can't exist. For example, if you have 3 over x minus 2, the question can give you any domain. Okay, in this case, any domain can exist except 2, because that way the denominator becomes 0, and that gives you something called math error. It's not infinity, it's math error. Okay, so 2 can't exist, any other number can exist. But sometimes the question chooses which numbers it wants to exist. Now you'll be like, oh, does that mean that some numbers cannot exist? No. But if the question specifies that, so okay, x can't be 2, okay, that's for sure. So even if the question says x is 2, then that's capping. Okay, so that's not possible. But they can say x greater or equal to 3. Does that mean that 1, 0, -1, -2 can't work? No, they can. But in this case, the question only wants to focus on the numbers greater than 3. Okay, but 2 can never work. No matter what the question says, 2 can never work in this case. So denominators can never be 0. Remember, denominators can be negative. Okay, and square roots can never be 0. Sorry, square roots can never be negative. My bad. You know, I make mistakes. I'm sorry. Square roots can never be negative. Square roots can be 0. So suppose you have square root of 2x minus 5. Anything works, but this can't be negative. 2x minus 5 should not be negative. So means x should be lesser than 5 over 2. That's it. It can be 0. Square root of 0 is 0. Okay. Now, that was all for what a function is, its domain, its range, blah, 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 blah. Okay. Now, I want to get into this idea called composite functions. Now, composite functions has many complications. Okay. You know, I said I'll cover 90% of it because 10% of it is complicated. All that 10% is in composite functions only. So I'll only cover the 90% of it. But the 90% of it is very simple. The 90% of it is very simple. Okay. Suppose I have fx equals to 2x plus 5. And suppose you want to do with two functions. I've already used f, right? So I'll use a different one called gx is equal to x squared plus 4, suppose. Okay. Now, if I want to put 2 inside fx, I'll write it like this, right? Fx is equal to 2 times 2 plus 5. Means I'm putting 2 inside x. If I want to put it here, I would do like 2 squared plus 4, 8. I'm putting 2 inside gx. Now, composite function takes it to the next level. It says fgx. Huh? fgx. What is this? Because f2, okay, you're putting 2 inside fx. g2, okay, you're putting 2 inside gx. fgx is the same thing. You're putting gx inside fx. So instead of putting a number inside fx, you're putting a function inside fx. So in your Yakult machine, you're putting another machine inside the machine. Okay. So in that analogy, it might be a little bit hard to understand. But if you actually think about it, it's very simple. You don't want a number to go inside a function. You want a function to go inside a function. So instead of 2 going inside a function, gx is going inside a function. What's gx? X squared plus 4, right? So what did you used to do? If it was f2, you would replace x with 2. g2, you'll replace x with 2. Now replace x with x squared plus 4. And remember, if it's fgx, it means gx is going inside f, yeah? It doesn't mean f is going inside gx. It's always the right one which goes inside the left one. Okay? Okay, I know what you're thinking. No. The right one is the input of the left one. Okay, just in case, who knows who's thinking what, right? So the right one is the domain of the left one, like how 2 is the domain of fx. So x squared plus 4 is the domain of fx. So instead of, it will be 2 times x squared plus 4 plus 5. That's the idea. That's literally the idea. Now the thing is, sometimes they might ask you fx. So you put fx inside fx. It's also simple. It's f of 2x plus 5. You put 2x plus 5 inside of itself. So it's 2 times 2x plus 5 plus 5. Okay, then you can expand, simplify, whatever. Okay, fx can sometimes be written as f square x. Same thing. But does that mean that they're multiplying two functions? No. Fx times fx is not the same as ffx or f squared x. Okay, it's not the same. It's not the same. It's not the same. Think about it. If you square fx, you'll get a quadratic. This is still a linear here, so it's not the same thing. Okay, don't get confused by the notation. Now, there are many different types of questions they can have for composite functions. I just have one for you, and this is a relatively decent one, not too hard, not too simple. Okay, fx equals to x squared minus 1 for x is any real number. Gx is equal to 2x plus 3 for x is any real number. Okay, now I want you to find gf5. So now, like how we found fgx, this is fgx. We want fg5 or gf5. Now there are two ways to do it. First thing is you can just find gfx. Just find gfx first. Two ways to do it. Okay, so just find gfx first. Gfx would be g of x squared minus 1. G of x squared minus 1. So it will become 2 times x squared minus 1 plus 3, which is equal to 2x squared plus 1. Okay, but they want it as 5. They want input as 5. So gfx is equal to 2x squared minus 1. Now we have a new function altogether. Now we can say you put gf5. So it becomes 2 times 5 squared plus 1 becomes 51. Or another method is you could say that, hey, before fx was the domain, right? Gx was the domain, right? Gx was the domain. Now, f5 is the domain. What's f5? You'll be like, okay, f5 is actually 5 squared minus 1, which is 24. So f5 is the domain. 24 is the domain of g. So it's actually the same thing as g24, which is 2 times 24 plus 3, which is equal to 51. It gives you the same answer. It gives you the same answer. Okay. Now, there's another question I have, but I'm not going to solve this. This is sort of like what you can try on your own. Okay. Because this is one of the slightly complicated concepts which I don't want to cover unless you want me to make a video on this afterwards. Hx is equal to, or have a class on the same thing. Hx is equal to 4x minus 25. Remember, I haven't used f at all. That's my choice. Okay. Don't panic if it doesn't have. The question is GHX equals to 85. Nothing new. Okay. Like how you found FGX, you find GFX equated to 85. Okay. I'll just do the starting for you. It becomes G 4x minus 25 equals to 85. Please don't divide it. Okay, this is a function. It's not multiplied. Don't be like, oh, G is equal to 85 over 4x minus 25. No. Okay, so this is G times 4x minus 25. So it becomes 4x minus 25 squared plus 4 equals to 85. Now you can solve for x here. You'll actually get two values. One is 17 over 2. One is 4. The point is you'll have to reject 4. And only 17 over 2 will be the answer. Now you'll be like, why? Shamit, I got 4. Both of 4 is greater than 0. 17 over 2 is greater than 0. It satisfies both. So 4 should be accepted. Why are you rejecting it? That's a slightly complicated concept. That's what I want you to think about. If you can think about it, great. If you cannot, think about it more. Or if it's a real issue, which I feel, then I might talk about it later. Okay. Now, there's one more thing about composite functions. Again, this is slightly on the complicated side, which is why I won't explain it. But the thing is that I'll very quickly write it. Okay, if you want, you can see if this is something you want to know or not. If you don't want to know, it's okay. Again, this is on the slightly complicated side, which is why I'm not going to go too much detail on why this is true, unless you want me to afterwards. The domain of GF, X, of course, GFX, suppose, is this symbol is called subset. Okay, we would have learned subset. This is a subset of this, blah, 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 blah. Is a subset of the domain of F. Okay, I'm just going to write GF, okay, all this X, all, who knows? Okay, then there's this thing called range of GF is a subset of the range. I know my writing looks like a mouse, but it's okay. It's equal to the range of G. Then there's one more thing called the domain of GX should be a subset of the range of Fx for GFX to exist. Very important. No, actually, I'm not sure if they're very important. I haven't seen many questions based on this. But if you really feel, if you want to make sure that your concepts of functions are strong, then knowledge of this and knowledge of why 4 is rejected shows some strong understanding. Okay, if you don't know this, well, it shouldn't make a huge difference for your IGCSE Add Maths, but well, this is something which definitely enhances your understanding and might make sure that you don't make any other mistakes in other parts of functions. Okay, now moving on next. I think I might took a slightly over half an hour, but I'll try to be as quick as I can. Again, I want to give you quality as well and not just short content. 30 minutes is great, but what's the point of 30 minutes if there's no quality also? Okay, so I'll try to be quick but maintaining quality. Okay, now there's this thing called modulus functions. Okay, modulus is this line bracket. Okay, the point is anything which is inside the modulus, it comes out positive. Even if a negative number is inside the modulus, it comes out positive. Suppose you have modulus of 5, it becomes 5. If you have modulus of negative 5, it becomes 5. But if a negative is outside the modulus, well, it's still negative 5. Modulus makes whatever is positive inside of it. Okay, so negative 5 is negative modulus of 5 is still negative. Now, if your friends don't take Add Maths or are not sure what a modulus is, I have a prank which you guys can play on them. Okay, now there was one prank which I played on my friend. Okay, we were imagining that we have a company and the profit is $1,000, suppose. Okay, You can write this as negative of negative $1,000, right? Yeah, so me and my friends were finding different ways to express our profit. Okay, then I told one of my friends who does not take Add Maths, hey, how about I write your profit like this? See, negative, negative, positive, your profit is still $1,000. He was like, oh, cool, yeah, this works. No, this is negative 1,000. I know this is a very boring prank, like, oh, Shamo, this is a dad joke, whatever, bad joke. I'm sorry. Okay. But I hope that helps you explain understand what the modulus is a little bit better. Now, are we just going to get this? No. Okay, we'll get slightly something complicated. So suppose they ask you something like this. Modulus of 2x plus 5 equals to 3. Now, I have a question for you. This is equal to 3 with the modulus. If the modulus was not there, because see, modulus of negative 3 is also 3, and modulus of 3 is also 3. So 2x plus 5, it could have originally been equal to 3. It became modulus and became positive 3. It could have originally been equal to negative 3. This could have been negative 3, but because of the modulus, it became positive 3. So it could have been positive 3 or negative 3. So 2x plus 5, it could have been positive 3 or negative 3. And then you can solve it case-wise. 2x plus 5 is equal to 3. 2x plus 5 is equal to negative 3, and then solve. Okay. Now, there are many variations to this. Sometimes there is a modulus on both sides. And sometimes there'll be modulus inequalities. All that is in chapter 5 of this. Chapter 5 is in what I follow. But if you don't follow it, it's I'll upload it and then have a class on it soon also. Okay. But in functions, you don't need to know that. Okay. But yes, they might ask you something like modulus 2x plus 5 is equal to x plus 1, suppose. Same thing you just have to do, is equal to x plus 1, or it could have been negative. And then solve. Okay. One common mistake students might make is this thing called square both sides. They'll be like, oh, this might have been negative. Who knows? I'll square both sides, because whenever I square a negative number, it becomes positive. There's that idea which people have of squaring both sides, and they're not wrong, but it's very risky. Let's see why. Suppose I'm giving you this. X is equal to the square. Suppose I'm telling you that x is equal to 7. I'm telling you already, like, why telling you? Just follow. Okay. Suppose this was the result we have. Now, for some reason, I'm like, hey, let's square both sides. It becomes x squared is equal to 49. Now, if I want to try finding x again, it won't be square root of 49. It will be plus minus the square root of 49, which is plus minus 7, which is plus 7 and minus 7. Notice I'm getting a minus 7 extra. And this is not wrong, because minus 7 squared is 49. So it's not minus 7's fault that it came there. It's your fault that you squared both sides. Squared both sides doesn't give you a wrong answer. It might give you an extra answer. So in this case, it's given us an extra answer. Negative 7 is not wrong, okay? Negative 7 squared is 49, but don't square both sides. That's my point, okay? Now, moving on. You also need to know how the graph of modulus functions look like. Now, one thing you might be wondering, Shamo, till now we learned y is equal to x plus 5. Now you're teaching us fx equals to x plus 5. What's the difference? I was happy with this. Why did I need to know this? Very simply, this is specifically for graphs. This is for anything. When I say y is equal to x plus 5, I'm always implying graph. Okay? I hope that's clear. Okay, y is equal to x plus 5 only for graph. Okay, only for graph. Fx equals to x plus 5 could be for anything. You know, maybe your marks, for some reason, the function of your marks is fx equals to x plus 5. The teacher's like, hey, today's my birthday. Whatever mark you get, I'll give you 5 marks more. So, Shamo, what if you got 99? Ask your teacher, okay, I'm just here to give you an example. You won't get 104 though, out of 100. So, now, let's talk about the graphs. Suppose you have y is equal to x plus 5 normally, okay? I'm not sure how experienced you guys will be in sketching a graph, but this is how the graph of y is equal to x plus 5 will look like in terms of a sketch, okay? Y and x. This is a sketch, okay? This is a sketch. Now, suppose you have y is equal to modulus of x plus 5. What's going to be the difference here? Well, the difference is, because this is a modulus that this can never be negative, so it should always be positive. So suppose I have some negative value here. Suppose this is -3. Suppose x plus 5 is -3. Because of the modulus, it becomes +3. So this actually becomes +3 here. Suppose I have -5 here. It actually becomes +5 here. So all of the negative actually becomes positive. And this is actually a reflection across the x-axis. So like this. Actually, it's a symmetric reflection. So let me try making it symmetric. It should be symmetric across this point, okay? It should be symmetric across this point. So you won't have this and y is equal to modulus of x plus 5. Okay, there's another way you can write this. And then this is just, I'm explaining this to you. Y is actually just, the graph of y is equal to modulus x plus 5 is just y is equal to x plus 5 until -5. See, this region is just x plus 5, right? It's just the normal x plus 5 for after -5. What about for before -5? Before -5, it was supposed to be like this without the modulus. Now it became like this. I understand after -5, like -4, -3, it's like this. With or without modulus, it doesn't matter. But with the modulus, -6, -7, -8, it matters. So that you can see it's a reflection across the x-axis, right? A reflection across the x-axis is actually when you just negate the function. Because your y value, if you negate it, it changes to the other value. If I had a y value of +5, I negated it, became -5, I reflected it across the x-axis, or vice versa. So it's actually like this. If you want to think of it that way, this is called a piecewise function. Generally, the first method is easier. Just draw the graph of y is equal to x plus 5. Okay, the graph of y is equal to x plus 5 would have been like this. Erase the negative part and reflect that to the positive side. Okay, that's generally easier. If this helps you understand, or if you find this easier, then sure. Okay, there's a little bit of a complication when it comes to something as y is equal to 2 plus modulus x plus 5, because this 2 is outside. This 2 is outside. So what I would like to do is I will just draw the graph of y is equal to modulus x plus 5 first, and then I'll just add 2 to it. I'll just add 2 to it. How does that work? Now, skipping you the tears and the hard work behind it, y is equal to modulus x plus 5 will look like this. Now, if I have to add 2 to it, let me save some space here. Adding 2 to it, imagine, okay, y is equal to 2 plus modulus x plus 5. So I'm adding 2 to the y value. So it'll shift 2 units up. You feel it? It'll shift 2 units up because, hey, I'm adding 2 to the y value. Come on, get some common sense. So before this was 5 and this was -5. Now the graph is shifted 2 units up. Okay, it's a bad graph, but I hope you guys can understand. This won't be 5 anymore. This will be 7. 5 plus 2. And this point, what's this point going to be? What's this point going to be? Well, the x value will still be -5, but the y value will be 2. -5, 2. Because this point just shifted 2 units up to become something like this. So just shift 2 units up. Okay, they remain parallel, everything. That's how you can draw for this. Okay, there's this website called Desmos. You can play around with these a lot and practice a lot of questions. Okay, cool. And just in case, they usually won't do that, but if they say y is equal to 2 minus modulus x plus 5, you draw the graph of y is equal to minus modulus x plus 5 first. This will just be the opposite of this, so something like this, and then plus 2, so it will be something like this. Okay, but they usually won't ask you this, but just in case. Okay, that's all for y is equal to modulus functions. Now there's one last thing which we need to cover, which is inverse functions. Okay, which is inverse functions. Now suppose y is equal to, okay, no, suppose fx is equal to 2x plus 5. F of 3 will be actually give me 11. Now I want to find a function. So see, 3 is my domain, 11 is my codomain. Let's just write it down. 3 domain. I know I've gone slightly over the time limit, but I am trying to go on quality as well. So If you're in the class, then you can ask questions, and if you're not in the class, you can slightly pace it up, the playback speed to 1.5 times or something. Okay, and the complicated questions, the complicated concepts of this, I am not going to explain it here, because if you want it, I usually explain this in the tuition classes which we give. So I've explained this to those who attend tuition classes, because there's more time there and we can give more details there. Right now in this, because of the time limit, I've just explained this briefly. I usually explain this in detail with in the tuition classes. But if you still want to know about this, again, as I said, you let me know later. Okay, I'll think if I have the time to make that, because I have to make a video for every chapter, so it's going to be a little bit difficult, but please let me know, because I'm at your service. Okay, now back to the topic. 11 is the codomain. Oh, Shamo, you're making me emotional. No. Okay, 3 is the domain, 11 is the codomain. You focus on your study. 3 is the domain, 11 is the codomain. Now I want something in a way that 11 becomes the domain and 3 becomes the codomain. This is what I want. This is what fx gave me. I want a function which has like this will be f inverse x. How do you find f inverse x? See, x gave you y. Now you want y giving you x. So how I like to remember it is just flip the variables. Okay, first you can write fx as y, just another variable. You want to, x was giving you y, now you want y to give you x. Okay, just flip it, just flip the variables, make it, or you could flip the variables, you could make it x is equal to 2y plus 5, and then you could make y the subject. So it becomes 2y is equal to x minus 5, y is equal to x minus 5 over 2. So f inverse x is equal to x minus 5 over 2. Or you could have just made x a subject here directly. It would have been the same thing. But you would have gotten y minus 5 over 2. Just change it back to x. Okay, you could try. So x minus 5 over 2, if you notice, if I put 11, I get 11 minus 5 over 2, which is 3. So yeah, 11 is giving me 3. That's how you find inverse functions. Now, one thing which is very important about this, see, 3 was the domain, 11 was the codomain. Okay, now let's be a bit more general. Okay, suppose you have x as domain. You'll have many codomains for, see, if I chose one domain, if I chose the domain as 3, I will get one codomain as if I chose the domain as 3, I will get one codomain as 11. If I choose the domain as x, I will get many codomains. So I'm just going to write that as range. So I'll get range. So I will be getting a range in fx. Okay, or you could say codomains. It's not very clear, is it? I don't want to take a risk that you all can understand my beautiful writing. So codomains range. This is for fx. For f inverse x, we want the opposite, right? We want this codomain to be the domain, and we want to get the original domain back. That's what the inverse function is. When we put 3, we got 11. We want to find a function. When we put 11, we get 3. So we want to find a function, and that's actually what f inverse x is. That when you put these codomains or range, you get the original domain. Let's draw a two-sided arrow. So then actually you can see, by the way, this domain and this domain, I'm referring to the same thing, okay? I'm not saying that this domain is the domain of the inverse or something. I'm referring to these are the same thing. Okay, if this is A, this is also A. If this is B, this is also B. Now notice one thing. The domain of fx is A. Okay, and the range is B. But the domain of f inverse x is B actually. Why is the domain of f inverse x B? You'll be like, hey, codomains, range. See, the domain of f inverse x is B because you're putting B inside f inverse x to get A. You're putting 11 inside f inverse x. This 11 was the codomain or the ranges. You're putting that as the domain of f inverse x. So you're putting this this as the domain of f inverse x. So the domain of f inverse x is the range of actually fx. If you give it more time, the domain of f inverse x is the range of fx. Okay, I hope you can get full intuition behind it. If you can't, then watch the video again, or just think more. Okay, A was the domain, B was the range. I want to reverse it. I want to find a function for which when I put B, I get A. So means when I put the range as my domain. So when I put the range as my domain, so domain of f inverse x is equal to range of fx. You didn't understand? Okay, just one last time. I put 3, I got 11. I put A, I got B. I put 11 back inside. I put 11 inside my f inverse x now. Now I want 11 to be my input in another function, in a different function. To get 3 as my output in that same different function. So I'm putting B as my input. B, which is the range of this fx, is the domain of my different function, for which I'm getting A as the output. And here you can see A was the domain of fx. Here A is the range of f inverse x. Okay. One last time I'll explain, because there's only 2-3 minutes left for me, because I have nothing else to explain apart from this. When I put the domain, I got the codomain. I want to reverse it. When I put 3, I got 11. I want a function for which when I put 11, I get 3. So when I put 11, 11 is my domain for the new function, right? For fx, when I was putting 3, I was getting 11. Now I want the function f inverse x for when I put 11. When I put 11, that means when the domain of f inverse x is 11, I get 3. I get 3 as the codomain of f inverse x, which was the domain of fx. But now instead of codomain, I'm talking about ranges, because many domains, like domain can have many values, so many ranges. Many values can be for the domain, so many codomains, so range. Okay, I hope that was a bit more clear. Please give it a little bit more time. This is essential. This is very important. This is very important. Okay, sometimes they might ask you questions for these for 3 marks. They'll give you fx, they'll give you f inverse x. Then you'll need to use domain of something, the range of something else, to find the domain of the inverse, the range of the inverse, the range of fx, the domain of fx. They can ask you this for 3 or 4 marks. So you have to be a little bit careful in that. 2 more things, each will take 1 minute each. Okay. Here you can see x is becoming y, y is becoming x. It's flipping. It's flipping. X is becoming y in fx, and y is becoming x in f inverse x. So that means 2, 3 is becoming 3, 2. When the coordinates flip like this is actually a reflection across y is equal to x. When the coordinates flip like this, reflection across the line y is equal to x. So that means fx and f inverse x are reflections across y is equal to x. Okay. One last thing is, how do you find the inverse of a quadratic? Okay, this is something I really want to mention. So suppose you have plus 7. Okay. You want to find the inverse of this. You have to make x the subject somehow. Or you could do y is equal to x squared minus 6x minus 7. Oh, sorry, plus 7. This is a plus 7, plus 7. Sure, okay, x is equal to y squared minus 6y plus 7. How do you make y the subject here? How? There are 2 ways. The first way is a quadratic formula. This is a x squared plus bx plus c. So in this case, a will be equal to 1, b will be equal to -6 or -6, c will be equal to 7 minus x. Or you might as well write a y squared plus by in this case. because it'll give you y is equal to negative b plus minus root b square minus 4ac blah 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 blah, right? Another way is to complete the square. So x will actually be equal to y minus 3. Completing the square is something which you will do later on if it's the first time you're doing functions. If you already know what, if you're revising this like how everyone in this class is, and how many people might be just revising it because it's in one shot. This is how you will complete the square. You all already have an idea of it. So y minus 3 squared will be equal to x plus 2. Y minus 3 will be plus or minus the square root of x plus 2. Y will be equal to plus or minus the square root of x plus 2 plus 3. Now, just one last thing. There's one problem here. We are getting y is equal to plus or minus the square root of x plus 2 plus 3. You know how this looks graphically? There's a plus and a minus. There's a plus and a minus. There's a plus and a minus. This is a one-to-many mapping. That's why I mentioned it earlier. This will look something like how will this look? Okay, I'm not sure how it'll look in terms of axis, but in terms of shape, this is how it'll look. This is one-to-many. If I put one value, okay, I'm not sure how it'll look in the y-axis, so I'm not drawing there because I'll have to find the coordinates. If I put one value here, I'm getting two different values. This is one-to-many. So how do I do it? I could either take the plus only or the minus only. I could either take only the plus or only the minus. That way, if I take only the plus, it'll be like this. If I take only the minus, it'll be like this. That's why I'm still making it one-to-one. But for that, what I'll need to do, because see how it works was, this was the original quadratic. The inverse was like this because it's a reflection across y is equal to x. If I want only one part of this, I can't take the full part of this and only half of this. I will need to restrict the domain for this. So if this was the center point, maybe I could just take this point. So if this is a one-to-one, the reflection will be a one-to-one. Or I could have just taken this point so that the reflection is also one-to-one. If I reflect the whole thing, I'm getting a one-to-many. Shamo, does that mean that this can't exist? No, this is one. Everything can exist. Does it mean that this is not a function? It is. Many-to-one is a function, but its inverse is not a function because it's one-to-many. But if I restrict this to some point only after its point of symmetry or below its point of symmetry, then I can make sure that it's in. So if I make this one-to-one somehow, its inverse would also be one-to-one. This was just a very short, very quickly I explained it to you. Again, I explained it in more detail in the tuition classes, but we don't have that much time here. Again, if you want an explanation of it, just let me know. Okay, but this was the idea of functions as a whole. Okay. One thing I'll definitely say, try understanding all of this. Okay, I'll share this is called Jamboard. I'll share this with you guys. Okay, and try understanding why we reject 4. Okay, that's it for now, guys. Keep studying. And yeah, I hope you found this helpful. I hope it was not too long. I need to make sure quality and quantity both are of the right balance. Okay. So yeah, take care. Happy studying, and I'll see you in the next topic which we do, which is going to be on quadratics. Okay, we'll do every single chapter. Don't worry, I'm here. I'm here. Yes. Okay. Take care. I'm gonna end the video here. Until next time.